fatigue limit, endurance limit, and fatigue strength are all expressions used to describe a property of materials, the amplitude of cyclic stress that can be applied to the material without causing fatigue failure. Ferrous alloys and titanium alloys have a distinct limit, an amplitude below which there appears to be no number of cycles that will cause failure. Other structural metals such as aluminium and copper do not have a distinct limit and will eventually fail even from small stress amplitudes. In these cases, a number of cycles is chosen to represent the fatigue life of the material. Definitions: the ASTM defines fatigue strength, SNF, as the value of stress at which failure occurs after NF cycles, and fatigue limit, SF, as the limiting value of stress at which failure occurs as NF becomes very large. ASTM does not define endurance limit, the stress value below which the material will withstand many load cycles, but implies that it is similar to fatigue limit. Some authors use endurance limit, say, for the stress below which failure never occurs, even for an indefinitely large number of loading cycles, as in the case of steel. And fatigue limit or fatigue strength, SF, for the stress at which failure occurs after a specified number of loading cycles, such as 500 million, as in the case of aluminium. Other authors do not differentiate between the expressions even if they do differentiate between the two types of materials. Typical values of the limit for steels are 1/2 the ultimate tensile strength, to a maximum of 100 Xi. For iron, aluminium, and copper alloys, say is typically 0.4 times the ultimate tensile strength. Maximum typical values for irons are 24 Xi, aluminum's 19 Xi, and copper's 14 Xi. Note that these values are for smooth unnotched test specimens. The endurance limit for notched specimens is significantly lower. History: the concept of endurance limit was introduced in 1870 by August Watt Paragraph-Lair. However, recent research suggests that endurance limits do not actually exist, that if enough stress cycles are performed, even the smallest stress will eventually produce fatigue failure. Testing methods: tension compression Stinger samples are repeatedly switched between a tensile and a compressive load. Tension testing. Samples are placed under an oscillatory tension amplitude. Bending, torsional, see also, fatigue, references.